If you haven't used the Arduino IDE before, I'll show you how to get set up. There's only one important thing here, and that's really that we shouldn't use the new Arduino IDE 2.x.x, mainly because the terminal makes it really hard to copy lots of text out, and that's fundamental to what we're doing here. So we're going to scroll down to the legacy IDE here and select your OS. I'm going to go with Windows. And for now, I'm just going to say just download. We're going to skip all that and click just download. Yeah, let's download it. Okay, and let's go ahead and install it. All right, and we should be good to go. For this tutorial, we're going to walk through testing a untested button. It's not a brand new button. It's actually maybe about 10 years old, hasn't been activated on or off for about 5 years, is my guess. And it's going to be a little interesting when we do this, mainly because when I measured the on resistance between these two terminals, luckily the switch was set to on, it was around 30 kiloohms of resistance, which is pretty high. And what I've seen in the past is the initial few activations back and forth will tend to be quite noisy, and then it'll start to settle out into its kind of normal behavior. In terms of wiring, we're just going to take that switch, or it's already connected, go to one side to digital input 4, and the other side to ground. We're going to get the Arduino program, the sketch, from the bouncy-button GitHub page. So go to that page, and then head to releases. We're just going to grab the latest release here. And if we want to get absolutely everything, so the Arduino sketch plus the browser for offline use, we can grab the source code and everything there. But right now we're just going to grab the Arduino sketch, so that's this zip file here. So I'm going to save it to my downloads directory, and then I'm going to click to open it. Now I'm actually in a compressed folder here, a zip folder, so I'm going to just copy this. There's lots of different ways you can do this, but copy it, move back out, and then paste. It might be hard to see, but that's a zip folder there. You just need to get the BB benchmark folder out of the zip file, however you want to do that. All right, so let's double click into there. And now that we have the Arduino IDE installed, you can double click on the INO file. You'll actually see the Arduino icon here after you restart your computer, but I haven't restarted since installing. So we're going to just double click on it, and you can see it launches. So here is the IDE. Now, all you have to do is select your port. Well, yeah, make sure your settings are correct. It should just launch normally with Arduino Uno port. So when you first connect your Arduino Uno, it will figure out which port it is. You just have to select it. And we are good to go as soon as we click upload here. So it's going to compile the sketch and actually start to transfer it. So you can see it's uploading now. Don't worry about the memory issues. No, it's not actually an issue. It's just saying, hey, there's low memory available. Stability problems may occur, but we're super careful with how we use RAM, so it's not an issue for us. And click serial monitor. We should see. Okay, this is good. It's good that I did this. I forgot about a couple things. And just for mentioning here. So what we need to do is select 115 kilobaud. Select that. There we go. That looks better. So we'll go to larger screen. So if you want to easily clear stuff, we're going to click clear output, close it, and then every time you open the serial monitor, it causes your Arduino to reboot. All right, and now we are ready to start recording data. Now, before I forget, there's a couple of helpful things in here. So if you type the question mark and enter here, it'll bring up the menu here. What we're going to do is give a session title for this. So I'm going to type in STL for session title, and I'm going to say old rocker light switch. If you forget to do this until after, or you just want to add it in, this is all it really prints out for you. That's what the browser is looking for, so you can manually add that in. And if you wanted to add a description, you can also do that with SDS command, session description. Okay, we are good to go now. This switch is kind of old and janky. Okay, so the first release is good. Let's try the next bounce, or the first press. 16 milliseconds, not bad. I should mention with this switch too, when I was trying to measure the on resistance, luckily it was already in the on state. Okay, that was kind of what I was expecting here. This switch was being a bit weird, so... Oh geez, I'm not actually doing anything here, but it's triggering on its own. So this sometimes happens on old switches. I suspect the first couple presses and releases, this thing is going to be weird. So the releases are super clean, or quite clean at least. The presses are pretty slow here. All right, so we've recorded 80 tests so far. We're on test 81. And I've just did those, normal, gentle-ish presses, nothing crazy. But I want to do something more interesting here. I want to do some fast presses. And I want them to show up differently in the analysis so it's easy to separate. So I'm going to go with start section test. So I'm going to type SS. And it tells us there's different arguments that we can use. We could use custom if we want, but the standard ones are there. You probably want fast or slow. So we're going to just type in F for some fast presses. And again, this is all it spits out. So if you want to manually add that into your file, that's fine. Okay, so now I'm going to flick the button for a release and see what happens here. Actually kind of hurts my finger. Oh, yeah, that hurt. Okay, 131 milliseconds. Well, I'll keep doing this a couple times. Youch. Okay, we've got our 100 tests. We're on test 101. That's usually good for me. 80 normal, 20 fast. You can do slow as well. Copy all of this, put it on our clipboard, head back to the repo here. Oops. And we're gonna go to open up the GUI. There we go. We'll clear the below data, paste in our data, and then parse the below data, and then graph and analyze. I'm gonna hit F11, give us more space. Every time you change your browser, these graphs don't update, so you might want to click graph and analyze again to have it update. So yeah, we see some kind of crazy stuff here. That's 1.2 seconds worth of bounce data, which is kind of crazy. So let's scroll down here, and it is kind of what I expected here. It was in the initial first few tests, so I'm gonna just zoom in down here. Now, as I mentioned before, this button hadn't been used in years. Its on resistance was measuring kind of crazy around 20, 30 kiloohms. And this is where I'm going to do some future tests on wetting current, because this switch may have performed well initially if it had enough current to kind of like bust through the oxidization. If you want to, like if for some reason you wanted to say that, hey, you know what, these tests are totally invalid, you could go into your file and just delete these ones. So you could say, okay, test ID 4, let's delete that one. 5, let's delete it. 6, let's delete it. But what we might do is we might want to put in notes in here in our file or in the description to say, you know what, you might want to ignore these 3, 4. But you know what, let's just go ahead and do it. So let's open up a file here, or you know what, we can go back to our COM port. This makes it easier. We're going to put in the question mark to see all our commands, and we're going to type in SDS for description here. First time ever, well, maybe not ever used. First time used in years by on resistance. You don't want to write too many characters in here because it's limited to 63. So I'm just going to hit enter for now. And again, all it did for us was basically just put in this tag for the browser there. Let's save this to a text file. So I'll grab this. I'm going to open up Notepad++, save it here, and I'm going to add a bit more notes in here. Okay, so I'm going to save this file, and let's just pop it on in my downloads here. Old rocker light switch. Okay, so we got it saved. And now if we copy all this again, head back to our browser, we can unload data, clear below data, paste in our new data, and here we see our description there. So this is helpful for users. So let's exclude tests 1 to 20. So let's say exclude 1 to 20. Okay, so we should start at 21 now. All right, I fixed up the description a little bit just to make it a bit more useful for people. And one thing to note too is when you exclude tests or when you filter on different things, it updates the different sections here. So instead of having 80 tests here, we have 60, and our bounce duration again has been updated accordingly. Okay, so if we want to share this, you don't have to, but it would be awesome if you did. You head to the bouncy-button data repo here, and basically all you got to do to contribute is click on Issues, click New Issue, and get started. You'll have to be signed into GitHub for this. First thing we want to do here is take our max bounce time. So I'm going to head back to our report here. Our max bounce time, let's call that 244 milliseconds. So we'll say 244 milliseconds. We're going to call this a rocker switch. And I don't have a switch model for this. I didn't find one on there, so we'll say old rocker light switch. Okay, and this is important too. Or the report here has a lot of different things that you can fill out, but don't feel like you need to. Really, the most important part is sharing the raw data and some kind of switch description. Okay, so I'm going to scroll down a little bit here, and my whole window here is zoomed in like 150% to make it easier to watch on YouTube. So I'm gonna go full screen again to get a bit more space. Drag that down to see it a bit easier. And then type. So we're just gonna delete everything other than rocker there. Function, we're gonna say it is an off-on rocker toggle. And then we'll say unknown. The voltage and current rating. So if I flip over to my photos here, I took a couple photos. It looks like it is 15 amp, 120 volts. Oops, went the wrong place. So we'll say 15 amps, well, 120 volts, 15 amps. Product URL, well, let's delete this. How new is the switch? How do you like the switch? Anything else noteworthy? Nope. Okay, so switch description and photos, they're not required, but it's nice. So I'm gonna just make some more space there. And depending on your operating system and what you're used to, we can just copy a picture on our clipboard and paste it right here. I'll show you how that works. So I'm gonna go back to maybe this first photo here, and I'm gonna click copy image. The image is on my clipboard. I'm gonna hit paste, and you can see it just popped it in. Just to check to see that that actually worked, because sometimes it doesn't work. You can click on preview there, and there it is. There is our light switch. Okay, so we're gonna go back in. Okay, so I've pasted these in here. So let's head on to the next one. So Arduino model, I was just using I only have two Arduino Unos that I typically use, a dip version and an SMD one. So we'll just say dip. That's kind of for my own notes. Arduino, sorry, the pull-up resistor is the internal one. I measured it once. I might go back and link it later. How are the wires connected? So this one, it's nice and simple, screws, and that just kind of matters because if you're getting crazy glitches like we actually saw in this one, the security of the wire makes sense to note. Like if it was on alligator clips and we're seeing 200 millisecond bounces, it's like, well, was that the alligator clips slipping? All right, so this one we'll say started at, I can't remember, it kind of varied, so between 20 and 50K, so we'll just say, actually, I have it over here listed. It was around 30K, yeah, okay. Started at 30K, ended after all tests, less than 1 ohm. Nothing else connected, and this kind of matters because if you have something else connected, like an oscilloscope, it adds capacitance to the line. Okay, test setup, description, and photos. Optional, but appreciated. So I just took a couple photos. So paste that in there. Grab the next one. I kind of like adding photos because it kind of makes it feel a little bit more, makes it a bit more interesting, I think, for viewers. So now raw data. There's a couple different ways to do this. I'm going to bring up my folder here. So I'm gonna head down to download. So here's where I saved that switch. I'm gonna move this over just to the side here, and then I can drag and drop this in here, and it uploads my text there. So that's done. The summary image here. So I'm gonna head back to this part here, and just to be able to see more of the actual interesting data, if you click on Tight Export and then Graph and Analyze, it allows you to see, provide a better summary image for people so that they don't have to download everything to get the gist of what how the button behaved. If you're on Windows, you can go click somewhere here and then go Alt and Print Screen, and it'll capture just your current screen. Go away. Okay, so let's pop that in there. Puts it on my clipboard. I'm just gonna double check. Sometimes it gets messed up. Nope, looks good. All right, I'll head back up to the top. Click on right. And that's pretty much it. Oh, the one last thing here is test section details. So here we can see there's normal and fast. So here's where you can add a little bit of detail. Fast activations. But that's basically it. That's all it takes to add entry to the open source database. If you want to come back and add additional information in the future, which I sometimes do, you can click on your own issue and go edit. And so I'm just going to jump right down to the bottom, and this is where I would probably go ahead and paste some of the description that we already wrote into our text file. I'm just going to grab this here, come back to here, and paste it in there.